and this is going to deal with some ideas for polynomials. And the first is going to be multiplying polynomials. So let's read quick. When multiplying polynomials, we must multiply all terms of the first one by all terms of the second one. We will use a method called the box method to help us perform this operation when both polynomials have more than one term. So let's look at our first example. We have 3x squared times, and then in parentheses we have our second polynomial, which is 5x cubed minus 7x plus 2. This is regular distribution. We're going to take this term out front and distribute it through to everything inside. So we're going to multiply through. 3x squared times 5x cubed is going to be 15, and x squared and x cubed make x to the 5. Then 3 and negative 7 will make negative 21. X squared and x will make x cubed. And then lastly, 3x squared and 2 will make plus 6x squared. So that wasn't new. That's regular distribution, right? But let's look at the next one. We have 3x minus 2 and 2x plus 1. There are two terms in each of these. To help me, what I am going to do is I'm going to write the terms of one of my polynomials here on the left. And I'm going to make a grid. And then, on the top, I'm going to write the terms of my other polynomial, 2x and 1. Notice I respected the signs, right? 3x and negative 2, 2x and 1. Now, in each box, I'm going to multiply the appropriate values. 3x and 2x is 6x squared. Negative 2 and 2x will be negative 4x. 3x and 1, that's just 3x. And then 1 and negative 2 will give me negative 2. These terms I wrote in red are the terms of my answer. Now, I need to look and see, are there any like terms here? And yes, this and this one are both x terms. So I need to combine them when I write my answer. So my answer will have 6x squared. 3x and negative 4x, those add to negative 1x. Or just negative x, if you prefer, right? You don't need to write the 1. You combine the like terms with addition, right? And then minus 2. And that is how we use the box method. We get all of the products, and then we combine any like terms. Let's look at our next example. We have x squared, 3x, and 2. And then we have 5x and negative 1. We'll make our grid. Right? Notice 3 terms times 2 terms. There's going to be 6 boxes this time, aren't there? So I'm going to fill in my multiplications. X squared times 5x is 5x cubed. X squared times negative 1 is negative 1 x squared. 3x and 5x is 15x squared. 3x and negative 1 is negative 3x. 2 and 5x is 10x. And then 2 and negative 1 is negative 2. Now, let's look at like terms. X cubed has none. For x squareds, there's 1 right here and 1 right here. And then for x's, there's, let's use a squiggle line. For the x's, there's 2 of them, right? So there's some like terms to combine. So when I go for my final answer, 5x cubed stood alone, no like terms. X squareds, when I combine them, 15 and negative 1 is positive 14, right? X squared. 10 and negative 3 is positive 7x for those like terms. And then minus 2. So x squared plus 3x plus 2 times 5x minus 1 is equal to 5x cubed plus 14x squared plus 7x minus 2. So we can multiply them. Now, 3x plus 4 squared. Careful. Addition and exponents do not play nicely. I need to rewrite this problem using the idea of exponents. 3x plus 4 times 3x plus 4, right? Squaring means multiply the same thing together. Now, I can use the box method because we have 3x and 4 and 3x and 4 for our two polynomials, right? 3x times 3x is 9x squared. 3x and 4 is 12x. 4 and 3x is 12x. And 4 and 4 is 16 when I multiply. I got some like terms here, so I'll make sure I combine those when I go to write my answer. Let's see, 9x squared stands alone. 12x and 12x make 24x when I combine them. And 16 stands alone. So 3x plus 4 squared is actually 9x squared plus 24x plus 16. Notice if you try to just square both things, you'd miss this 24x. That's a big thing to miss. That can be, if x is 100, you'd be off by 2,400, right? That makes a big difference in your calculation. So make sure when you're squaring a polynomial, you rewrite the same thing twice. Now, that's the box method. There's one more method we can use, and that's when you have a 2-term times a 2-term. You might have heard FOIL before. FOIL stands for first, outer, inner, last. So first, outer, inner, last. So let's write x plus 2, 2x minus 3. And I wrote it huge so we can see what's going on. We're going to do the first. So we take the first two terms and multiply them together. That's going to give me 2x squared. Next, we look at the outer two. The outer two, that's x and negative 3, which will give me minus 3x. Next, we look at the inner terms, which are the two inner ones. 2 and 2x, which gives me plus 4x. And then we look at the last two terms, so the double last, and we'll use a squiggle Sharpie for this one. So here, squiggle Sharpie, we multiply the last two together. Notice I just made all possible pairings. I'm doing the same thing as the box method. I'm just using the word FOIL to help me remember all the pairings. I personally always use FOIL when I have the 2-term by 2-term, and I use the box method for all the other ones, right? You can only use FOIL when it's 2 terms times 2 terms. In our previous examples, you can FOIL this one, but you cannot FOIL this one. 3 terms times 2 terms, that's not 2 by 2. You could FOIL this one as well, right? So you can't always FOIL, but you can always use the box method. FOIL only works with 2 terms times 2 terms. Now, I was squiggle lining here. We had to do 2 times negative 3. That gives me negative 6, right? And so hopefully we can see that we can FOIL like that, right? Now, the last step is there's some like terms here to combine before I'm done with the problem. So I'll have 2x squared. Negative 3 and positive 4 make plus regular x, right? You could write 1x and then minus 6. Next we have another one we can FOIL, 2a minus 3b, parentheses, negative 5a plus b. So let's take a look here. Let's do the first. I'm not going to color code it this time, just for the sake of time, so you're not watching me just mess around with all my different pens. 2a times negative 5a is negative 10a squared. Then we'll do outer. So we did first, then we'll do outer, which is 2a times b. So that'll be plus 2ab, right? When you multiply those together, it's 2ab. Then we'll do the inner. Negative 3b times negative 5a. Negative and negative make a positive 15. And we have a and b again, so I'll write ab. And then we do the last. which is negative 3b times positive b, which will be negative 3b squared, right? And the last step, whenever you FOIL, you got to check if there's like terms. There are like terms, right? So when I write my final answer, it'll be negative 10a squared plus 17ab minus 3b squared. And that would be my final answer. So feel free when you have a 2-term times a 2-term to use either the FOIL or the box method. Both are fine. It's totally up to you which one you prefer. Like I said, I always use FOIL for the 2 terms, but I use the box method for the larger ones, right? So now, factoring. So factoring is the reverse of what we just did. So factoring is a technique to help simplify polynomials. In order to factor a polynomial, we have 2 main methods we will consider. We'll want to perform the first method first whenever possible, and then we'll use the second method if we can. So the first method we have is factor out the greatest common factor. Greatest common factor is always usually said GCF, greatest common factor, right, GCF, of all terms. The second method is factoring a trinomial. Tri means 3. Think tricycle, right? Or triceratops, right? Triceratops have 3 horns. Tricycles have 3 wheels. Trinomials have 3 terms. And then if there's no factoring possible, then we say the polynomial is prime. So sometimes you can't factor. You can't always factor. Just like with numbers, right? The number 7 has no factors besides 1 in itself. It's a prime number, right? Same thing for polynomials, prime polynomials. So let's look at our first example. It says, greatest common factor, the first technique. If every term of a polynomial is divisible by the same thing, then we can divide out that common factor. So let's look. 10x to the 5th minus 15x cubed plus 20x squared. And the first thing I want to identify, is there a GCF? I'm trying to factor out the GCF. To do this, I look at the numbers and the variables separately. So first I look at the numbers, 10, 15, and 20. What is the largest number that divides all 3 of those numbers? What is a common factor of all of those numbers? Well, 5 divides 10, 15, and 20, and is the biggest number that divides all of them, right? Nothing bigger than 5 divides all of these numbers. So I'm going to put 5 right here. Oops, this is squared, isn't it? Little typo there. That's a 2. There we go. So now let's look at the x's. I have x to the 5th, x to the 3rd, and x squared. They have an x squared in common, right? X to the 3rd has at least 2 x's there, and x to the 5th has at least 2 x's. So in my GCF, I can also include the x squared. They also have x squared in common. Now, I want to divide each of these by this. So I'm factoring out 5x squared. Then I'll have a parentheses, and 10 divided by 5 is 2. And if I take x squared out of x to the 5th, I'm left with x to the cubed, right? Minus 15 divided by 5 is 3. And if I take an x cubed and take x squared away from it, there's 1x remaining. And then 20 divided by 5 is plus 4. If I have an x squared and I'm factoring out an x squared, it's gone. The x squared is gone. So, my factored answer is this. This is the problem factored. We're going in reverse of what we just did. Notice, I could distribute and check. 5x squared and 2x cubed, and I distribute 10x to the 5th. 5x squared and negative 3x, 15x cubed. 5x squared and 4, 20x squared. You can always double check your factoring by re-multiplying. So this is my factored form. I have factored out the GCF. Now, let's look at another example. Here, we have 9x to the 5, y to the 2, plus 12x to the 3 minus 15x. Now, the first thing I want to look at is there a GCF? What is the GCF? I'm trying to factor out the GCF. I better look for it. First, I look at the numeric coefficients, 9, 12, and 15. And I ask myself, what is the biggest number that divides all of those numbers? 9, 12, and 15. Well, 3 divides all of those and is the largest number that does so. 3 divides 9, 12, and 15, and nothing bigger than 3 divides all of them. Now, I look at the variables. Right away, notice there's no y's in my last two terms. So my GCF cannot have any y's in it. It's common factors. There's no y's over here. So I'll look at the x's. All of them do have x's, though. Which has the least? This one. It has a single x. That's how many they have in common. All of them have a 3x in common, right? So when I go to factor, I can write 3x, parentheses, I'm factoring out the 3x. Let's look. 9 divided by 3 leaves me with 3. I'm taking one of the x's away, so I'll have x to the 4. And the y squared didn't go anywhere, so I leave the y squared. Next, 12x cubed. 12 divided by 3 is 4. X cubed, factor out an x, leaves me with x squared. And then 15x divided by 3x. 15 divided by 3 is 5. Make sure you keep the subtraction right. It's subtracting 15, so I need to make sure I respect my signs. If I factor out the x, it's no longer there, so I'll close out my parentheses. So that's factoring out a GCF. And that's the first thing you always want to look to see if you can do, is factor out a GCF. The second type of factoring we want to consider is factoring trinomials. So for a given trinomial that's in the form x squared plus bx plus c, here b and c can be any numbers, positive or negative. We factor the trinomial by doing the following. Write out all possible ways to multiply two numbers and receive the value of c. So we write out all possible multiplications that give us c. Step 2, for each of the pairings from step 1, we look at their sum. One of these should be equal to b. So next we look at a sum. And then step 3, we can then use the pairing from step 2 to write the factored answer. I think the best way here is to see it done. X squared plus 5x plus 6. So my c value is positive 6. So I'm going to write c equals positive 6. And I'm going to make a little table for myself. I'm going to write b equals 5. Now, how can I multiply to 6? Well, 1 times 6 is one option, or 2 times 3, or negative 1 times negative 6, or negative 2 times negative 3. And those are all the possible ways to multiply to positive 6, right? Positive times a positive or negative times a negative both give you positive, and 1 and 6 and 2 and 3 are the factors of 6. Now, I add these factors. 1 plus 6 is 7, 2 plus 3 is 5, negative 1 plus negative 6 is negative 7, and negative 2 plus negative 3 is negative 5. Now, right here, I got my answer. I got b equals 5. For each of the pairings from step 1, these are the step 1 pairings, right? The ways to multiply c. One of them should be equal to b, this one. We can use that to write the answer. The way you do this is you write x, and then you take your pairing. There was a positive 2, and then the other one is x, and you take the 3, so plus 3. So x squared plus 5x plus 6 is the same as x plus 2 times x plus 3. You could check this by foiling if you wanted to. You could refoil this back to start the beginning. We're factoring so we can check. Factoring and multiplying are opposites of each other, right? They go opposite directions. We can factor or we can multiply. Let's look at the next example. X squared plus 4x minus 12. So same thing. Once again, I'm going to make a table. C is negative 12. Be careful of the signs. And B is positive 4. Now, there's a bunch of ways to multiply to negative 12. Or sorry, there's a bunch of ways to multiply to 12. 1 times 12, 2 times 6, and 3 times 4. Now, none of these give me negative 12 multiplied. They're all positive. I need to make one of the numbers negative in order to multiply to a negative number, right? A negative times a positive is a negative. So I need to make one of these negative. I am going to be clever here. I want my numbers to add up to a positive number. So that means the smaller number needs to be negative, right? Negative 1, negative 2, and negative 3. I only need to check these ones because I know B is positive. You could have written 1 and negative 12, 2 and negative 6, and 3 and negative 4 as well. All 6 of these pairings multiply to negative 12, but it can't be any of these because I know I need to get a positive in the end. So these ones are no dice here. Negative 1 and 12 make 11. Negative 2 and 6 make 4. That's the one I want. Negative 3 and 4 make 1. So we wanted the 4. B equals 4, right? So my answer, x squared plus 4x minus 12, when I factor it, I'll have x minus 2, x plus 6. I used the pairing that gave me the result I wanted. That is how we factor trinomials. Notice if you check down here, 1 and negative 12 make negative 11, negative 4, and then negative 1, right? You just get negatives of all those same numbers. That's why we didn't check them. We knew it was supposed to be positive. In my third example, I have x squared minus 8x plus 15. So here, C is equal to positive 15, and B is equal to negative 4. Now, multiplying to 15, the only possible ways to do it are 1 times 15 or 3 times 5. Oh, sorry, B is negative 8. Right, B is negative 8, right? Negative 8. 1 times 15 and 3 times 5 are I get 15. Now, 15 is a positive number. You can also multiply 2 negatives to get 15 as well, right? You can also, positive numbers can be multiplied by 2 positives or 2 negatives. Now, which of these adds up to negative 8? Not that one. That's positive 8, that's not right. Not that one. Ah, this one is negative 8, right? Negative 3 and negative 5 add up to negative 8. So when I write my answer here, it'll be x minus 3, x minus 5. Now, notice I've always written them in, the order I wrote them. It doesn't matter. If you wrote x minus 5 first and then x minus 3 second, that's fine too. Same here. If you wrote x plus 6 times x minus 2 instead, same thing. You just got to make sure the sign, the negative is on the 2 and the positive is on the 6. Here they're both negative. You just got to make sure you have the right signs, right? The order doesn't matter. You can multiply in either order. So I could have written here x plus 6, x minus 2 as well, right? That means the same thing. Now, we got a couple more examples of this. Let's take a look here. X squared minus 2x minus 3, x squared minus 2x and minus 3. Now, let's take a look here. C is equal to -3, and B is equal to -2. Now, to multiply to -3, 1 times 3, but one of them needs to be negative, so I could do -1 times 3, or 1 times -3. I know it can't be the first one because that gives me a positive number, so I'll cross that option off, right? It gives me +2. The second one gives me -2, right? 1 plus -3 is -2. So when I write my answer, I have x minus 3 and x plus 1, right? And I can always double check by foiling. Now, my last example, x squared plus 2x plus 7. Here, C is equal to 7, and B is equal to 2. Filling out my table, the only way to multiply 7 is 1 times 7. That's the only way to get to 7. Or -1 times -7, right? 1 times 7 gives me 8. -1 times -7 gives me -8. Neither of those are equal to 2. This is prime. None of my combinations worked. I cannot factor this polynomial with the techniques I have at hand. So I would say it is prime. It is unfactorable. It is not prime because 7 is prime, though. Like, that's just a happy coincidence. Like, this could be a non-prime number and still have the same problem. It just happened to be a prime number. Now, an example with both techniques in one, let's take a look here. 3x cubed plus 12x squared minus 15x. I need to factor this. Right away, I know it's not a standard trinomial because it's not x squared plus something x minus c, or plus c, right? It doesn't match the standard format for trinomials. So I should look for a GCF first. GCF. Let's see. 3, 12, and 15. Them all divide by 3. X cubed, x squared, and x. Those have an x in common. So I can factor out a 3x. What is left? Well, if I take 3x away from this, I'm left with x squared, right? 3 divided by 3 and take the x out. 12x squared, let's see, 12 divided by 3 is 4. X squared, take out an x, gives me x. Minus 15x, let's see, 15 divided by 3 is 5. And I took the x out, so it's gone. Notice what's left in my parentheses after I factored out my GCF. It's a trinomial. It's a trinomial where C is -5 and B is 4. Ways to multiply to 5. The only ways to do it are 1 times 5. I can do -1 and 5 or 1 and -5, right? Negative. I need at least one of them to be negative. -1 and 5 gives me the desired 4. I'm just going to stop there. I don't even have to check this one. I found the one I'm looking for. So my answer, the 3x is still out front, parentheses. I have x minus 1, parentheses, x plus 5. This portion here became x minus 1, x plus 5. Don't forget the 3x out front, though. That was the first thing you factored, right? So this question combines both techniques into one. You factor out a GCF, and then you factor the trinomial. Always go in that order. If there is a GCF between your terms, always do that first. That's what the instructions said, right? That was our technique. Oops. Factor out the GCF. We'll want to perform the first method first, right? Now, let's look at notes. Not all polynomials can be factored. Boom, example. But when attempting to factor, make sure you exhaust all possibilities before declaring a polynomial prime. Don't just say it's prime because the first thing you tried didn't work. You got to try all combinations, right, before you can say it's prime. And then you can always check your answer for a factoring problem by multiplying the factors back together. Here, I could FOIL these together to go back up to here, right? X minus 1x plus 5 foiling gives me x squared minus 1x plus 5x minus 5. If you cleaned up a little bit, you'd get this. Distributing this gives me 3x cubed, 12x squared, minus 5, boom. Going backwards is the stuff we did on the first page. Factoring and multiplying are opposites of each other. And that